You guys see my screen, right?
Yes.
Yeah.
Yes.
All right. Like I said, first thing we're going to talk about is decimal points. So when you take a number like this, so this is, last time we saw that when you have a comma here, it's a whole number, it separates 3 groups. So this is not a comma, this is an actual decimal point. So each decimal point has a name. So again, this is a decimal point because this is not a comma. So we have the decimal part. And also have this part to the right of the decimal point is called the whole part. It's basically what we talked about last time, only the whole part. So the decimal point is here. Each one of these has a name. So the very first one is called the tenths. Okay, not the tens. This is the tens. This is the whole part. We call these the tens. This one is the tenths with a th at the end. The second one, what do you think the next one is called? If this is the tenth, then the next one will be?
Is it the no,
The
hundred?
The hundreds, that's right.
Oh.
And this one is just the regular hundreds. This is again the whole number. Then you have the thousands. Thousands with a THS. And this is the, actually, let's redo these. So we're only interested in the, whatever this number was, it doesn't matter. So again, today we're talking about decimals, so we're interested in these placement values. So the tenths, the thousands, the hundreds, and the thousands, and the 10,000s, and so on until you get to the millions. This part, that's what we explained last time. So last time we didn't have a decimal point. We only had whole parts with commas here, not these. This is actually the ones.
The tens.
This is the tens, and the next one is?
Hundreds. 100.
That's right, the hundreds. The regular hundreds, not the hundredths. Okay, anything after decimal has this th at the end, as opposed to this. We can say, for example, 0.1. So this has 1 in the tenths. 1 in the tenths. Okay, so this is 1/10. This is the same as this, which is basically 1/10. And if you have something like this, so this is again the tenth, then the hundredths. So the tenths and the hundredths. So this is the same as 1/100, which is 1/100th. And you keep going like this. So depending on, so what placement is this? What is this digit called?
Thousand.
Thousands, that's right. So out of 1,000, which is 1. The third one again is for the thousands here. Okay, so that's how you name those decimal points. We're probably gonna get a chance to come back to these another time and talk about decimals in detail. Now, let's see how to round decimals. So this is just a quick definition of the concept of the decimal point. Now we're gonna see how to round decimal. So when you have, for example, 1, what is it? 1 point, let's say 7 and maybe 8 here. So this is a decimal number, 1.78. And let's round this to the nearest tenth. So first we need to locate the digit that's in the tenth.
I fixed the AWV. I don't know why I didn't save before. Because I did everything for that guy, Husker.
I'm sorry, are you talking to us?
Yeah.
Well, I'm sorry, what did you say? Couldn't hear that.
Yes.
What was your question again, Alexandra? I couldn't hear the question. Could you repeat it? I don't know if she was talking to us or somebody else. Anyway, so round in decimals. So again, the nearest tenth. What digit is in the 10th position? 7, right? So that's what you want to do first. Locate that digit. So the 10th, as we saw up here, this is the tenths, the hundreds, and the thousands. So when the question says round to the nearest tenth, so you locate this one, and then you look to the right of that digit. You look at this number. If this number is 5 or more, we add 1 here. If not, we don't add anything here. We just turn it into a 0. So again, you locate the placement value or the decimal, then you look to the right. Are we adding 1 to 7 or not?
Yeah.
Yeah,
Why is that?
Over 5.
because it's 5 more.
Exactly. This one is 5 or over. So we're going to add 8 here. So it would be 1.8. And just turn everything else into zeros. Whatever numbers you used, for example, this one turns into 0. So we just rounded this to the nearest tenth because that's what the question said. Let me give you another example. Let's say you have 2, 5, 8, 1. Same thing. Let's round this to the nearest tenth. Again, you want to locate the digit that's in the 10th position. What digit is it?
8.
8. That's right.
Oh.
Okay. Now we're at 8. We look to the right of 8. Based on this number, are we adding 1 to 8 or not?
No, because it's below.
Exactly. If it's below 5, you don't add a number here. But if it's 5 or more, you do add 1. In this case, it just turns into 25.9, and you turn the other one into 0.
Mm-hmm.
Okay, that's for the 10th position. And for the other positions, it works the same way. The 10th,
Why do you turn it to 9 if you
I
don't
think
count?
it's still the same. Yeah, A is still the same. Right?
No, it's supposed to be 80.
Shouldn't it be 25.80?
oh, yeah, you're right.
Yeah.
I'm sorry. I don't know why I wrote 9. I was thinking about the previous example. You're right. You guys are ahead of me, so that's good. That means you're on board. Okay, so again, it all depends on the position. It works the same way. Whether you have the tenths, the hundredths, the thousands, or the 10,000s, whatever it might be. First, locate that digit, okay? You underline it, and then look to the right of it. Let's do the same thing now, but with another decimal, with another placement value. So to the nearest, this time, let's say hundredth. And I'll give you some decimal here, 5, 4, 1, for example, and 8, 3, 7. All right. What digit is in the hundredths position? What number is in the hundredths position?
The 8.
The 8, yeah.
Okay.
3.
The hundredths. Hundredths. You guys see here?
Get 3.
Oh, the
No,
5.
three.
5. The 5.
3.
Oh no.
I did 3.
5.
The 3s are going to be
3.
a 10.
3.
So I said the hundredths, okay?
Oh yeah, yeah, the 3.
3.
These are regular hundreds. This is
Mhm.
regular hundreds, as we saw last time with the whole numbers. So they may sound the same, but be careful with the writing or the spelling of the decimal place. Okay, now that we have that, what do we look at after that?
We look up, the number is at the right.
That's right. We'll look to the right of this, which is this number, which is 7.
7.
Good.
We add in 1 here or not?
Yes.
Yeah.
No.
We are
Why?
adding.
Because of the 7?
We add 1 because it's up to 5.
Exactly. It's 5 or more. So we add 1. Unless it was 4 or 3 or 2 or 1, then we don't add. So we're gonna write this,
Okay.
then 8. So we add in 1 here, turn that into 4. And anything after this turns into zeros. Anything after the placement value, the hundredths, turns into zeros. Okay, so we just rounded this to the nearest hundredth.
Do you always have to put the 0, or is that?
You don't have to put it, but probably a good idea to put it just to see what changes in the number.
Okay.
So let's do another one here. Let's say 59. Okay, 25.59. What digit is in the hundredths position? What digit is in the hundredths? Hundredth.
9.
The 9. So we look at the 9. Well, actually, you know what? Let's put some number here. So the 9 is in the hundred position. So now, are we adding 1 to 9? Or it doesn't have to be 1. Let's put 4 so we don't confuse it with adding 1. So the 9 is in the hundred position. Then you look to the right. We have 4. Are we adding 1 to 9?
No.
That's right. Not, because this is less than 5. So we're just going to turn this into 0, and this stays the same. And basically, we do the same thing for all other decimal points, but be careful here to locate the correct decimal. And be careful here. So the decimals start from the tenths with a th, but the whole number, it does not start from the tens, as I put earlier. It does not start from there. It starts from the ones, tens and hundreds. For the decimals, they don't have ones here. They only start right away from the tenths. Okay, it's very important. Pay attention to the wording of the question. Okay, they may sound or look quite similar, but they are not.
I'm a little confused. I'm gonna be honest with the position.
Yeah. Did you were you here last time with the whole numbers?
Yeah.
Okay, so we talked about this in detail, but be careful here again. This one starts from the tenths. The whole number starts from the ones.
For the 1.
Okay? The difference is if you see s at the end, that means it's to the left of the decimal. I mean, to the right of the decimal. Otherwise, if it's this, it's just a regular number, regular whole number here. Be careful again with the comma and the decimal point. This is a decimal point, then this is a tenths, hundredths, thousand. If this is just a comma, that means the whole thing is the entire number is the whole number. So if this was a comma, this would be the ones, the tens, hundreds, thousands, 10,000, 100,000, then the millions, then the billions, and so on. Let's do one more example to the nearest. Probably the maybe this time 10,000. And it's important again that we look at the end of this. This is th. That means we're talking about a decimal point to the right. not the thousands, not the regular thousands, which would be here. So if you have something like this, and let's say I wanted to round this decimal number, it has a decimal point, to the nearest 10 thousandths. First, again, you want to locate this precisely. What digit from here is in the 10,000 position? Which
Okay.
number?
9.
So again, so we have the tenths, the hundredths, we have the thousands. What's the next placement value after this? What comes after the thousands?
100.
Before the hundred?
No. Tens.
The 10,000, that's right. The next digit here, so this is the thousands. If we add another digit here, will be the 10,000s. That's what we're interested in here. So this is, so again, the tenths, hundredths, the thousands, the 10,000s, the 10,000s. Now, let's say if we had some number here, let's say probably 5. So this is the position. It has 5 to the right. Okay, this is the number we're interested in. Are we adding 1 to 3?
Yeah.
Yes, because this number is 5 or more. If it's 5 or more, we can add 1 here. So this turns into, so this whole part doesn't change. That's not what we're interested in. Decimal point, and then 8, 9, 1, and 4. Okay, this is what changed. So we added 1, 2, 3. Okay, so be careful when you round your decimals. Be careful with locating the decimal points. Now we're going to see another example or another section. We're going to see how to estimate numbers. We're going to see how to estimate by rounding. Sometimes you can just look at the numbers. Instead of doing the addition and subtraction, you actually just round them into some convenient numbers, and then you add those numbers in your head quickly, and you get your answer faster. As an example, you can also, in addition to rounding the decimals, which is this part, we can also round the whole part. Okay, you can round that to the whole part. And you pretty much work the same way. You just locate the decimal. And then, once you look at that decimal, you look to the right of it. I mean, you look at the digit. Let's do some examples with whole numbers.
So I have a question.
Yes?
So the decimal, if they asked a question rounded to the nearest, let's say hundreds or thousands, right? It's going to be after the decimal?
What was the last part of the question? I couldn't hear it. I'm sorry. Is he going to be asking for the decimal, you said?
I asked that if, let's say, yeah, like for the nearest thousands, is it going to be after the decimal, the nearest thousands, with the THS?
Yes. So if you see THS, that has to have a decimal, okay? If you don't see a THS, you know you're dealing with just a whole number. Let's do that. Let's do that now.
Okay.
Okay. So this is decimals. Now I'm just gonna do rounding of whole numbers. So rounding whole numbers is even easier. So you don't have to worry too much about decimals now. Like I said earlier, we're gonna spend a whole class or maybe a couple of classes talking just about decimals in the future. Let's just talk about whole numbers here. So 7,821 and there is a comma. Again, this is not a decimal point, it's just a comma to separate the hundreds from the thousands. Let's round this to the nearest. Maybe nearest tenth. Here's 10. Okay, so notice here, we don't have th because this is not a decimal. The nearest 10. Okay, what digit, what number here is in the tens position?
8.
Mm.
And it, maybe
8.
which number? In the,
8.
It's 2.
the 2, that's right. Ones, tens, hundreds, thousands. These are whole number, there's no decimal. So this is,
Oh.
Ay, I get confused.
okay, you see here, ones, tens, hundreds. Okay, the concept is the same.
Because I'm hungry
1, 10, 100.
and I'm not gonna focus.
Also, 2.
That's right. So 2 here. So this, basically, we don't add 1 here because,
Este pelo, fíjate, cortaste el pelo.
please mute your mic if you have noise there. So again, we're gonna turn in, we're not gonna add anything to this because I can hear some background noise.
What a noise.
Típico.
Please mute your mic, I mean, whoever has noise. All right, so, okay, give me the whole number here. Give me the rest of the number. So 8, then 2. So the digit here turns into 0. So this is our placement value. Turn this into 0. So that's 0. Another.
Como porquería.
So
Vamos
7.
que más
7,000. Why should I mute myself?
Let's do another example, this time with the nearest hundreds. Nearest hundred. I say this is a number, again, it's not a decimal number, it's just a whole number. We can add a little comma here. So we want to round this to the nearest hundred. What digit is in the hundred position? What digit is in the 8? That's right. Ones, tens, hundreds. It's 8. Then what do you do after that?
Leave it alone.
We leave it alone because we look to the right of it. We have 4 here. 4 is not big enough. It has to be at least 5 in order to add 1 here. And since it's not 5, so we're just going to turn this one 0 into 0, and anything else after that will turn into 0. So do not add 1 here. So this part stays the same, so 5. And everything else turns into zeros. Again, it's a whole number. That comma is not very important, but you can still put it here if you need to. Okay, so one more. This time, let's do the nearest, maybe thousands. Nearest 1,000. And all right, this whole number, what is it rounded to the nearest 1,000? What is it?
The 7.
The 7 is in the, or the 7 is in the 1,000 position, right?
Yes.
That's the first step. Ones, tens, hundreds, thousands. Okay. So now we're here. What do you look at after that?
You got the 100.
Okay, so this is, all right, so we have 7 here. We located it. What do you do after that? Are we adding 1 to?
We add 1.
That's right,
After.
because this one is 5 or more. So we're gonna add 1 here. This turns into 8.
8
What happens to these 3?
becomes 0.
All of these turn into zeros. Exactly. So we add 1. Again, only if this one is 5 or higher. If it's below, for example, here, we did not add to 8. It stayed the same. So this turns into 2, 7. And you got to write all these zeros. You have to write them. With the decimals, when you round, you may skip this 0. You may omit the 0 and you'll be fine. But with the whole numbers, it has to be, you have to put the zeros. Otherwise, the numbers changes, okay? If you don't put these, so we are going from 27,000.
28,000.
I'm sorry, 28, you're right. So make sure you add, you put all the zeros for the numbers that changed. If you skip them again, if you don't put these, you've changed the numbers dramatically from 27,000 to just 28 for no reason. Only in case of decimals that you may get away with not putting a 0. But to be safe, just remember to always put 0 when you change a number, when you're rounding it. Okay, so that's the idea of rounding decimals. You don't have to worry about this part too much again. Like I said, don't worry about too much. You may not even see it in the homework. We're gonna talk about this in detail another day. But for now, just focus on whole numbers. And again, the placement of values for whole numbers are, they start from the ones, tens, hundreds, and so on. Now let's do some estimates. Like I said, this is useful for us when we try to find an answer faster. An answer that we don't care if it's accurate, just close enough. So if we just estimating things, we use the rounding usually, like I said, mentally, because it makes the additions and subtractions very fast and convenient. I'll give you an example. So rounding. To estimate. Of addition or even subtraction. So let's say trying to add, start with smaller numbers. Say 24, want to add that to 35, maybe even 71. So let's try to, so if you try to do this in your head, it might not be as simple, but if you round them to the nearest 10th or nearest 10, you can already see, if you round this to the nearest 10, what would it be, the nearest 10?
20.
If you round this to the nearest 10, you look at 4, right? I mean,
20.
20.
that's right, 20, and this one?
40.
40, and this is?
No, 70.
70. So those can add up pretty quickly. You can say 2 and 20 and 30, that's 50, and plus 70 is 120. Mentally, very quickly, as opposed to doing the actual addition and simplifying it. Okay, so let's redo that again slowly. So this is a tens position. Since we have 4 here, we're not adding 1, so we can say 20 plus. Same thing here. So here we have 5 or more, so we can add 1 here, turns into 40. And since we have 1 here, it's less than 5, so this stays. We don't add 1 here. So this can be easily added. So 2 and 4, 6, plus 7, 13. Okay, so that's 130. Actually, I said 120 earlier or something, but it's 130. Let's do just 2 numbers. Let's say you have 85 plus 11. What is this approximately? Not the actual, an estimate of this, not the actual, the exact value, just an estimate by a rounding.
80.
Now, if you
No, 90.
that's right. If you add 1 here, it would be 90 plus
Plus 10.
plus 10, and this is 800.
Mm-hmm.
Okay. That can be useful when you add or subtract. Let's say you're talking to someone on the phone. Say your manager called you, and the manager just wanted a rough estimate of something, of the sales or something. So the manager doesn't have time, has a few seconds, he just wanted to get an estimate number, not an exact value. Maybe later when you do the reports and the accounting and everything, that's when you write everything in detail to the nearest whatever decimal point you want. But when you estimate, you just do things quickly. Let's try to do this one. All right, so let's try. You want to add these two, but again, you want to estimate them first. So the highest placement value here is the hundreds, okay? Ones, tens, hundreds. So let's round this to the nearest hundreds.
700.
Exactly. So you can already see the answer to this. So what's the total here? An estimation. 700 and
Plus 200.
not
That's
200.
250.
If you look at,
300.
that's right, 300. So if you look at 2, it's 5 or more. I mean, if you look at 2, we have 5 here or more, so we add in 1 here. So this one, you don't add, so it's 700. Then you work this out in your head again quickly. You say, oh, it's 300. And of course, you're going to say 2,000. So this can be done like at a glance by, you know, in a few seconds. Okay, let's round another one maybe this time. Well, let's throw in some numbers like this. And then 841 350. Again, we just want to get an estimate here. So you round each one to the highest, whatever placement value, to the highest, or the one that's on the left, the most left one, which in this case is the thousands. This one is the hundreds and hundreds. Okay, what is this one rounded to the nearest 1,000? So the 1,000 is here. And what do you do with these? Do you add 1 here or not?
No.
That's right, because of these two. Always look to the right and see if we can add 2 and 1. So we're not adding, so this is 1,000 roughly. And this one will be
800.
800 roughly. We're not adding because of 4. And this one?
400.
400. And these can then be added either, you can say, and either do a column, add them, or you can just estimate them from here. What is the total of this? If you look at it, 1,000 and 800 and 400. You may want to start from these two. What's 800 and 400?
1,200.
1,200. Add another 1,000 to that.
1,300.
2,200.
20. So 1,200, 22, 100, right? 1,000 from here, and 12,000, or 23 actually, right? We do 1,200, right? This is an estimate. And then this 1,000 here. Is it? So 22, right? Okay, so that's a rough estimate. Again, it doesn't have to be accurate. It's just for a quick off-the-cuff answer. But later, to present things in detail, you want to add all these using the traditional method we learned last time to get the exact value. This is just an estimate. That's pretty much for rounding and estimating. I hope this helps you not just in the math class, but you can use it, you know, when you do the actual things, daily things like shopping or looking at things online or looking at windows, you know, shopping windows or store windows as you walk by. You don't want to stop by and do the math and pull out a calculator and the pen. Instead, you just want to do that at a glance, just estimate things, and you get a rough estimate of the value. And later on, like I said, you can write things down, calculate the actual value. All right, so our next thing would be The next unit we're talking about is 1.8 and 1.10. Which one should we do first? We have 1.8, 1.10, which is about just word problem. So let's talk about 1.8 and the order of operations. Okay, so sometimes or often you don't just have one operation like we saw last time, adding or multiplying or dividing two numbers. You may have a whole operation with multiple numbers, multiple operations, maybe parentheses. So we need to perform that in a specific order. You cannot just do it the way you want or from the left. You have to follow a specific order, which we call the order of operations. I'm pretty sure you're familiar with it. What is that acronym? What is that word that summarizes all the operations?
Please excuse my dear Aunt Sally.
That's right. Please excuse my dear Aunt Sally, or I like to remember it that way, or as PEMDAS.
PEMDAS, yeah, I know what it is.
PEMDAS, okay? So basically, before we develop this, let's just do some simple examples. If you have 2 plus 5 times 1. So we have two operations here. Which one do you think is done first, has priority?
Multiplication.
Multiplication. Even though this seems convenient or tempting because it appears first, it doesn't have to be done first. So it's not 2 plus 5. A lot of people were making this mistake. I was making this mistake myself back in the day, but then I learned the order of operations. So the multiplication is done before the addition. So for this acronym, we have P, which stands for parentheses or brackets, E for exponents, M for
Multiplication.
that's right, D,
Division.
division, and
Addition.
that's right, addition, and finally
Subtraction.
subtraction. So this is your order. You want to start it from here, going this way. You look for this first, then if you don't have it, if you have it, you do it. If not, you go to the next. So in this case, for example, this has to be evaluated first. So 5 times 1, that's 5. Then plus the 2 here, that's 7. If you do this one first, it will definitely not be the same. It will be 2 plus 5. Or will it be the same? 2 plus 5, 7 plus 1. This is just a coincidence that both this one first and this one first will result in the same thing. Just a mere coincidence. So before we do more examples, let's talk about the exponents because we're going to need them here for the order of operations. So let's talk about them first. So as you know, exponents, what is the other word for exponent?
Power.
Power, that's right. It's when you have something like this, 3 to the second. What is 3 to the second equal to?
9.
9. How do you get 9? If you break it down.
Multiplying, yeah, 3
3
times
3.
3.
3 times. This is the base. And this exponent or power. Basically, you repeat the base as many times as the power. If you have 5 here, then you would write this 5 times, 3 times, 3 times. So the exponent power, it's not 3 times 2. A lot of people make this mistake. It's not 3 times 2. It's rather 3 times itself as many times as the power, which is 9. What is 2 to the third? Or what is the breakdown of it first?
2 times 2 times 2.
Exactly.
Repeat
So
the
4
base
times
3
2.
times.
Which will be
16.
8.
8. That's right. 2
Oh,
times
yeah.
4 plus 2 is 8. So this is one of the common mistakes. People think it's 2 times 3. It's not. I have to break it down first. One more. Or the other way around. 3 to the 4. It's not 3 times 4. It's 3 times 3. How many times?
4.
4 times. 4 times. Because the power is 4. 1, 2, 3, 4. Then you don't have to do these all at once. I always recommend that you do these 2 at a time and then repeat again. If you do it all at once, you make it confusing. So these 2 together, that's 9 times. These 2 together, another 9, which is
81.
81. That's right. So this is 2 to the third, 3 to the fourth power, 3 to the second, and so on. Okay, so let's see how to incorporate this into some order of operations with parentheses and everything. I'm going to start easy with simple examples, and as we simplify, we'll do more problems. So let's do this problem here. Maybe -4 here. All right, so now we added more stuff. So we have, what is the operation here, by the way?
It's a multiplication.
That's right. So multiplication, we have parentheses, we have addition here, +1, -4. So going back to the order of operations, what is it that we do first?
Parentheses.
Exactly. So P for parentheses. Always look for parentheses first, as in here. If you have them, do them first. When we say parentheses, we mean inside of them, not outside. Work inside. So this got to be done first. So that's 4. And everything else should remain the same. Only one step at a time. So here we did parentheses. What comes after parentheses? Exponents. Do we have an exponent here?
No.
We don't have an exponent here or power. So we're going to skip the E, go to the M. Do we have multiplication?
Yes.
Why do I have, this shouldn't be here. So 2 times, 2 times. So we're going to do this multiplication now before anything else. That's 8. Bring down the 4. Okay, that's multiplication. Finally, just one operation left, subtraction. We put the 4 here. So this is subtraction. This is your final answer. Okay, go by PEMDAS. It's always helpful to write it down in front of you first and just go over those one by one. Okay, is everybody okay so far?
Yeah, I understand.
Everybody else, you guys all right? Before I do some longer problems.
Yes.
Okay, so as we go, the expression is going to get a little more complex. So please let me know if you have any questions at any moment. Let's do, this time I'm going to try to do something like this. Let's do maybe 2 here. And possibly 1. So what we do first here? Or actually, let me add in some parentheses to make it more interesting.
All right.
So 1 here, and maybe 3 plus 1. You have 4 times in parentheses 2 minus 1 to the third power plus 1. So this may seem a little confusing. It's not. It doesn't have to be. So you always look at the order of operations and follow that order. You don't have to invent anything. Just go by the steps. So what do you do first?
Exponent. Exponent.
That's right. Let me write PEMDAS again here. So first, look for not the exponent, but this is what we do first, the parentheses.
Oh, yeah, but
Okay, so we're doing this first. Nothing else changes, only what's inside. 2 to take away 1, that's 1. Just bring everything else down. Now, after the parentheses, we have the exponent. Obviously, again, look closely here. It's not 4 times 1 first. Do not do that. A lot of people make this mistake. You see a power here, exponent has priority over multiplication. So do not do this multiplication yet. Instead, we can evaluate this. What is 1 to the third?
1.
That's right. Any 1 to any number is 1 times 1 times 1, which is 1. It's not 3, okay? That's another common mistake. 1 to any power is always 1. 1 to the power 100 is also 1. So think of it this way. So only this will change now. So we're going to put 1 here. Okay, so we did the exponent here. All right, next, do we have a multiplication?
Yes.
Multiplication is here. So we're going to do that. So 4 times 1 is 4, plus 1.
Plus 1.
Finally, only one operation left, the addition. We don't have division, so we want to addition. And this turns into 5. Okay, so that's your order of operations. It's pretty simple to use. When you see it, when you see a long expression, again, don't panic. Just look at the expression, look at the order of operations, and do one at a time. Don't do more than one operation. Also, it helps when you write the whole line every time, not just what you evaluate. Write the whole line and just do one operation at a time, P, E, M in this case. Everybody else, you guys okay?
Yes.
Okay.
Can you do one more like that?
Yes, sure. I'm gonna do more as we go. So it's gonna get, like I said, the more we go, the more expressions or more numbers and operations we're gonna have. Now, okay, we're gonna do something close to this. Let's say, all right. So what happens, or what is done first here?
The exponent.
That's right. Again, it's not 5 times 2, exponent, because it comes before multiplication. 2 to the third, we saw it earlier. What is it? 2 to the third is 2 times.
The base 3 times.
That's right. So exponent. What's next?
Multiplication.
That's right. 5 times 8, that's
40.
40. Take away 7. Now we can do the subtraction. That would be 33. What else? Let's do another one. Now I want to show you another one. But be careful here. Okay, 15 divided by 3 times 2. What do you think we do first here?
Multiplication.
Okay, so if you follow this order, yes, we should do multiplication first. But actually, when we have these two next to each other, the multiplication and division, we do the left one first, then the right one. So these two are done left to right.
Left to right. Also, division go first.
Yes, so whenever you see these two together, same thing with these, also left to right.
Okay.
Same thing with these. So multiplication and division, I know it looks like M first and then D, but if you see them next to each other, directly next to each other, you want to evaluate the left one first, whatever it is, then the right one. So 15 take away 3 will be 5, and then the 2 down. So again here, we did the division. Now we're going to do the multiplication. So that's 10. If you do it the other way, it will not work. It will be 6 here. 15 divided by 6 is not 10.
Okay, when we see like a division, we follow the same order, right?
Yes, so if you see these two together next to each other, whichever comes first is done first. Here's another one. So if you have, for example, 8 divided by 4, no, actually, say 3, what 4 times 2 divided by, let's say, 8. Okay, which one is done first here?
So I think division.
Yeah,
Oh,
Four times two.
multiplication.
it's always left to right.
Because it's first now,
That's right.
in this case.
Well, the first one, whatever the first one is done first. So 8 here, divide by this 8, which is of course 1. Same thing applies to addition and subtraction. If you see them next to each other, evaluate left to right. So let's say you have 5 minus 1 plus 4. Okay, even though it says here addition first, then subtraction, but if they are next to each other, we do left to right, whichever appears first. Obviously, which one we do first here?
So 4.
That's right. Evaluate this one first. Plus this 4. This turns into 8. We have 2 plus 3 minus 1. Same thing, so left to right. The first one first, then this one. So 5 minus 1, which is 4. Okay, so addition and subtraction, they kind of have the same category. But that's why we do them left to right. Multiplication and division also go together, so we evaluate them left to right. So pretty much the same thing every time. So let's do and plus. All right, this one here may look a little interesting, a little complex, but again, no need to panic when you see this. We have the guideline, we just have to follow it. Where do you start from? What do we do?
Parentheses.
That's right, parentheses. We have 2 of them. We have this one and this one. We can evaluate both at the same time because it's the same operation. So 2, and make sure you write everything else. Only thing that will change is this and this. So that's 4 to the second plus 3. This over here turns into 2 to the third. So we're done with the parentheses. Next, we have 2 of them.
Exponent.
That's right, exponents. We have 2 of them, this and this. Also, we can do them at the same time. Again, do not do 2 times 4 yet. The exponent first.
2, 16.
That's right. 4 to the second is 4 times 4, 16.
Plus 3, 8.
That's right. 2 to the third, again, is 8. What comes after the exponent? Multiplication.
So
We have
multiplication.
2 of them, here and here.
2,
You can do both.
12.
So 30
15 is 32,
plus,
and 24.
that's right.
6,
Finally, we have these 2.
56.
That's right, 56. Okay, that is the order of operation. Just follow it. Make sure you use the right steps. And there's only one correct answer because there's only one order, which is balance. Let me see. Almost done. Maybe one more thing here. Find the root of a number. Use all the properties. Something called the root of a number, or the square root. It's somehow here in the book. So let's see, we gotta cover it. So when you times a number by itself, those are 3 times 3. That's the same as 3 to the second as we saw earlier. So we say we square the number. So when you times a number by itself, that means we square it, which is 9. So when you go from here to here, we square the number. But when you go backwards, we get the square root. It's basically the opposite. So to go back from 9 to 3, we say the square root of 9 is 3.
It's 3.
And it's basically, we say what number multiplied by itself to get 9. The number that multiplies by itself is
3.
3. Same thing with square root of 25. What number multiplies by itself to get 25?
5. 5.
5. That's the whole concept of square root. Is that's just the opposite of squaring. So you go backwards. I'm sure you're familiar with these as well. What number multiplies by itself to 36?
6.
6.
That's right, 6. We have cubes also, we have other powers, but we're not going to talk about that today. We're just going to make things a lot simple. As we go, we'll introduce more topics and more tricks. I believe that should be it. Okay, 1.9, 1.10. 1.10 is just word problems. We'll basically just ask you to give you a word problem, and you take that word problem, you turn it into an operation like this. Let's see if we can do an example. Because the problems are not always written like this, not always written in that format. Sometimes they're words. We need to translate them and then use these rules to simplify them. Okay, so here's some keywords. Oops. Some keywords here that we use when we translate. So all these are pretty much synonyms or equivalents. When we add, we say something plus something or something more, and so on. Subtraction, you can use different words to mean subtraction, division, and so on. So be familiar or get familiar with these words. So when you see them, use the appropriate operation to translate them and solve problems. So it's basically let me drag this over a little bit. So the last section now is we're going to call this. This will be number 5, number 6. We're going to call this word problems. So again, my pen is a lot slippery.
Word problem.
Okay, this let's say so. Let's say the sum of 2 and 5 subtracted or multiplied by 6. Okay, so that's a sentence rather than an arithmetic expression. So let's translate this. So this will be sum, meaning, so we have some keywords. We have sum and we have, of course, multiply. They're pretty straightforward. The sum means
Addition.
addition. So the sum of 2 and 5, so 2 plus 5 multiplied by 6.
Times 6.
Then you use the order of operations as always to simplify. So what operation is done first?
Multiplication.
That's right, multiplication. 5 times 6 is 30. 2 and then 32. Sometimes you can get tricky, like the quotients and decrease, increase. So be careful with those. Let's do another one here. Say the product, or the quotient rather. So the quotient. The quotient is for
Division.
division. So the quotient of 21/6 multiplied by 3. So the quotient, remember that, it stands for division. So 21 divide quotient of two numbers. Quotient of two numbers. These numbers are 21 and 7.
Divided by 7.
21 and 7. Then multiply.
Multiply by 3.
Right? And again, when you simplify, be careful with the order of operation. What is done first?
Division.
Division. Okay, division left or right. So that's 3
3
times 3.
times 3, 9.
Right. So that's how you deal with word problems. Let me see if we can do another one. Almost, or most of these are pretty straightforward. There's a tricky one here that you need to pay attention to. So, for example, 15, or rather, let's say 4 subtracted from 10 and decreased by, let's say, 3. Okay, so we have two keywords here, subtracted and decreased. What's the meaning of each one? Subtracted, obviously, is subtraction.
Subtraction.
Decreased means
Subtraction.
also subtraction. The opposite of decrease is?
Subtraction, yeah.
Okay.
Opposite of decrease is increase.
That's right, it will be increase. We rewrite this. And how do you translate? Be careful with the first part. 4 subtracted from 10. How do you translate this? How do you write it?
In this case, 10 go first.
Exactly. So 4 subtracted from 10.
From 10, yeah.
So it's not 4 minus 10. It's the from that goes first. So whenever you see subtract from, the from goes first.
Okay.
Unless it says 4 subtract 10. I don't even know if that's formal when we say 4 subtract 10. But when you say 4 subtracted from 10, remember the from goes first, then the subtraction. This is a very common mistake. People, when they see subtract from, they keep the same order, 4 minus.
Yeah. The result could be negative if they do.
That's right, it will be different. So decreased by another minus here, 3. Then you do left or right. Again, additions and subtractions together, left or right. So this is, we're going to do this first. That's 6. Take away 3, which is 3. Okay, so one more about subtraction. It can be tricky. The difference of 11 and let's say 7. Increased by let's say 2. Okay, the difference of 11 and 7 increased by 2. How do you find the difference of 11 and 7? In what order do you do the subtraction? So let's translate the first part, the difference of 11 and 7.
11 minus 7.
Exactly. So when it says difference, you don't have to switch the order. You switch the order here when it says from, the from goes first. For these, difference, you just keep the same order. 11, take away 7. Increased, of course, is the opposite of
Increase by 2.
decrease. And by 2. So again, left to right when you have these two together. So that's 4 plus 2 and 6. Okay, so depending on the keywords, we have plenty of them. So get familiar with these. So if you see any of these words in the homework, use them appropriately.
Okay.
And that pretty much concludes our lecture for the day. Please rewatch this lecture.
Okay.
If you ever get confused or if you have any questions, so always rewatch them and review them before doing the homework. And also, if something is still not clear, please let me know during our next meeting, and we're gonna go over that.